In 2017, researchers from Iowa State University, USDA Agricultural Research Services conducted a study using MSPRS-resistant starch. The objective was to further examine these mechanisms. The data from the study looks at the impact MSPRS has on piglet gut health and explores different modes of action. This chart illustrates the fecal microbiota genera changes found in the control group and the group fed MSPRS-resistant starch. The inclusion of MSPRS led to a drastic change in the microbiota profile in the gut. What they found was that bacteria that favored resistant starch proliferated, and that many of these beneficial bacteria produce butyrate. The Clostridium genera are the healthy microbes that do produce butyrate, and you see an increase in these microbes with the piglets fed MSPRS, while Campylobacter is considered an opportunistic pathogen and is more prevalent in the diet without resistant starch. This resulted in an increase of butyrate production. Piglets fed MSPRS were found to have a different VFA profile than pigs fed the control diet. The butyric and lactic acids were present in the MSPRS group in higher proportions, likely because of feeding these butyrate-producing bacteria preferentially. Butyrate is considered an important metabolite in its role to fuel the colonocytes found in the hindgut. An increase in lactic acid indicates an enhanced probiotic bacterial activity. An improved VFA profile is consistent with what we see in Dr. Nyachoti's study, with a low inclusion rate of MSPRS-resistant starch. These three genes are support for the mucosal layer, stimulating secretions from the epithelial cells. These secretions, or the mucus layer, creates a trap for pathogens, which can then be inactivated by IgA, which is an immunoglobulin. MSPRS feeds microbes, and it's suggested that butyrate from these microbes stimulate epithelial cells that then release IL-6, which signals the secretions for the mucosal layer in a complex process that is critical for maintaining the mucosal barrier. The results of this study showed MSPRS-resistant starch in piglet diet causes significant changes in the intestinal microbiota. The study showed an improvement in butyrate production and indications of an improved epithelial barrier function.